Let's take a look at the negative rule of exponents. So the negative rule of exponents comes into play when we are simplifying a quotient. So let's say, for example, you have x squared divided by x to the third power. So here we would use the quotient rule of exponents because we have exponential expressions of the same base x. The quotient rule says that I would subtract the exponent. So this would be x to the second power minus 3, which results in x to the negative 1. So how can I rewrite x to the negative 1? Or we should ask ourselves, really, what does x to the negative 1 mean? And x to the negative 1 can be rewritten as its reciprocal, which is 1 over x to the first power, or 1 over x. So let's talk about why x to the negative first power is the same thing as 1 over x to the first power. If we think about x squared divided by x to the third, we can rewrite this as x times x in the numerator divided by x times x in the denominator. So we can see here that that cancels out and this cancels out, leaving us with 1 over x. So that's why x to the negative 1 is 1 over x. Now let's consider if we had something like x to the negative 3. What does that mean? That means 1 over x to the third power. If I have something like x to the negative 14th, that's 1 over x to the 14th power. So that's what the negative exponent means. Okay, we would rewrite it as the reciprocal. So why don't we take a look at a couple of examples together? Let's consider negative 3t to the second power, negative 3t to the second power, divide that by negative 3t to the eighth power. So here, notice that we have a common base, which is that negative 3t, right? And we can apply the quotient rule here. So that's 2 minus 8, which will give us negative 3t raised to the negative 6th power. So here we would just simply rewrite this using the negative rule of exponents as 1 divided by, and notice I'm keeping that negative 3t inside parentheses, and I'm raising that to the 6th power. And you don't have to simplify this any further. We can leave it like this, okay? Let's consider another example. F to the 47th power divided by f to the 49th power times f to the first power. So in the denominator here, we can use the product rule. So that would be f to the 49 plus 1, which is 50th power. And then here, let's use the quotient rule, f to the 47th power minus 50, which results in f to the negative 3. And then we would rewrite that using the negative rule of exponents as 1 over f to the third power. Okay, one more example. 2k to the fourth divided by 5k to the seventh. So I'm going to break this apart as 2/5 times k to the fourth divided by k to the seventh. So here I've got a common base of k, so I can take care of that by using the quotient rule. So let's just rewrite 2/5 here. And then k to the fourth divided by k to the seventh using the quotient rule gives me k to the 4 minus 7, which then gives us k to the negative 3. And so then we can rewrite this using the negative rule of exponents as 1 over k to the third. So then let's multiply the numerator. 2 times 1 is 2, and the denominator, 5 times k to the third, is just 5 times k to the third. So there you have it.